This screencast is a part of our final assignment on information, visualization, and interaction. We used the Hubway bike sharing dataset, which was a part of the Hubway Data Visualization Challenge. The objective was to visualize 500,000 bike rides in the city of Boston. Interesting patterns and insights were derived by means of user interaction. This is the Hubway co-occurrence matrix. The y and x axis show the origin and destination stations respectively. Different intensity of colors represent the frequency of trips, with lighter colors indicating a weaker connection and vice versa. You can hover over the matrix to interact with it. This box here updates your hovering position in real time. This helps to distinguish stations that are popular from those that are not. For instance, you can clearly see that station 36 is very popular, whereas station 37 is clearly not. The most important insight that was gained is that for most stations, trips usually end at the same station they started. This is demonstrated by the diagonal with high intensity cells.
The Hubway Historical Data Visualizer. All bike stations have been mapped onto their respective positions. We can zoom in to have a closer look. If you mouse over, it displays the name of the particular station. Heat map shows that these stations are in close proximity. You can also activate bike routes or deactivate them. Clicking on a particular station places a blue border around itself. It colors all other stations that trips are made to from the selected station. So this legend basically shows you how these stations are colored. If you hover over to this info box, it shows you that the median frequency of all trips is 14. So the circles that are yellow indicate the trips which are less than the median, orange trips that are less than twice the median, and red trips that are greater than twice the median. As you can see, there are line connections between the highlighted stations as well, with varying opacities which indicate the frequencies of the trips between the source and target station. You can also choose to hide these trip connections. The station needs to be re-clicked for it to be updated. The satellite mode without labels actually helps to visualize the stations better as well. You can right click the stations as well. This shows the total number of outgoing trips as well as the incoming trips. Note that right now we are in the outgoing uh, mode. Since no filters are changed right now, you can see that all the trips are being showed. These two figures are the same. Now let's investigate the differences between casual and registered riders on weekends and weekdays. So we can start by filtering out Saturday and Sunday. So actually before that, let's say let's say Boylston Station. So there are a total of 8,000 almost 8,700 trips, right? So if we were to filter out Saturday and Sunday, we have 6,700 trips. So if we only keep the casual members, we get about 1,100, 1,200 trips. These trips account to 18% of the total trips. So now if we look at the same casual riders on the weekend, we have about 1150 trips, right? And the total number of trips on the weekend are actually only about 2000. So these trips for the casual riders on weekends actually account to 58%, whereas on weekdays they were only accounting to 18%. This shows that on weekends, typically casual users are more than registered users. This is an interactive bar chart displaying the difference between outgoing and incoming trips for each station. The stations that have more bikes incoming than outgoing are displayed in red to the left of the y-axis. Likewise, stations that have more bikes outgoing than incoming are displayed in green to the right of the y-axis. You can hover over stations and the corresponding ID is displayed. Ideally, stations should have an equilibrium between the number of in-station and out-station bikes. For example, this isn't near equilibrium. This is why the bars that go beyond 4% or 6% on either side are of particular interest. Hubway would have to redistribute bikes accordingly to make the system more efficient.